Welcome to the Job Shop Show, where we talk with the owners, suppliers, partners, and customers of custom manufacturers. Listen and learn the secrets of top-performing job shops, the tools, techniques, and backgrounds that have made them successful, all in the quest of raising the bar for custom manufacturing. I'm your host, Jay Jacobs. This episode is sponsored by Paperless Parts, connecting buyers and suppliers of custom manufactured parts. The Paperless platform is a secure, ITAR-compliant, cloud-based manufacturing system for suppliers that reduces the amount of time spent on sales, estimating, quoting, administration, and order processing. It offers seamless integration with the accounting and ERP software tools that shops already use, such as QuickBooks, E2, and JobBoss. Paperless Parts was founded with a mission to make manufacturing more accessible by streamlining the quote-to-cash process. Spend less time quoting and more time selling. Hello, Job Shop fans. Jay Jacobs here with the first recorded episode of 2020. Before we begin with today's guest, I wanted to mention something that puzzles me. The Institute for Supply Management, ISM, a national organization and one that's pretty prominent in the news, puts out a monthly number that supposedly gauges the health of manufacturing. Above 50, manufacturing is growing. Below 50, manufacturing is shrinking. December's number was 47.2 and was the fifth month in a row below 50 and the worst number since June of 2009. So the headlines are screaming manufacturing slowdown. But here is where I'm confused and why I said supposedly gauges the health of manufacturing. Myself and the team at Paperless Parts, we regularly speak with job shop owners, both prospects and customers. And in late December, what we were hearing almost unanimously from them is that the year is going to be getting off to an awesome start. I understand Boeing's decision to halt production of the MAX plane may be having an impact, but what is the disconnect? So I ask you as a listener, if you have some thoughts, please reach out to me because we are just not seeing the feedback from our shops saying that their business levels match what this ISM is putting out. Anyways, today we are joined by Eric Nekic with Lang Technovation in what promises to be a gripping discussion, pun intended. I sought Eric out because his company has come up in a couple podcasts of the Job Shop Show, and then independently, a former teammate of mine at Rapid, who's since joined another shop as their technology implementer, told me that he'd selected Lang as their fixturing solution. So what's going on here? Work holding, fixturing, clamping. It's not a sexy subject and doesn't involve computers, but some top shops are investing in Lang and making this a focus point. Eric is going to help us understand why. Welcome to the Job Shop Show, Eric.
Hey, thank you for having me, Jay.
I'm going to take advantage of you having lots of shops as customers, Eric, both independent and captive. What I mentioned before about manufacturing numbers, does that jibe with what you are seeing and hearing out there?
Not at all. No. From everything we see here, manufacturing is alive and well and very, very healthy coming into 2020.
Okay. I'm really curious, what is the disconnect? Where are they getting the reported numbers that are showing a slowdown in manufacturing? And are they measuring parts of manufacturing that I guess you and I just don't consider part of the typical manufacturing or at least the job shop side of it? So anyways, that's just a curiosity for me. I want to start out our conversation with a quote on your LinkedIn page, a very recent one. And it says, "For a long time, clamping technology was about holding a workpiece more firmly. We take a different approach. We ask, how can we increase the quality of a milled part while reducing costs?" So what does that mean, Eric?
Well, I think what it means is that, work holding, in my opinion, and I would think a lot of our competitors would even agree, is an oftentimes overlooked factor in the manufacturing process, right? In its simplest form, how are we going to hold the part securely, and how are we going to hold the part rigidly? I think that the new trend, and at least maybe going back for the last 5-10 years, is, are there ways that we can solve other manufacturing challenges with work holding? And that comes to, in its earliest form, that trend was, you started to hear terms like quick exchange and modularity, compact, and now as we transition into 4- and 5-axis machining, or even automated manufacturing, you start to see that work holding is really kind of rising to the occasion to assist those processes, to really complement them.
Interesting. 4 and 5 axis. Matter of fact, the fellow that I mentioned, the former teammate, I believe he specifically bought your technology for a 5-axis machine that they were bringing in-house. So that's an interesting trend. But before we get into that, you mentioned it is often a overlooked area of job shop manufacturing. And I have to agree from a former job shop owner perspective, because I didn't pay any attention to the clamping, fixturing, work holding technology. I just assumed it was there, and it never came up in any discussion points as having the ability to make a difference in the quality of a part or helping to reduce the part cost. So before we jump into all this, talking to me as a job shop owner, teach me about clamping. And first of all, maybe we can talk about the different terms: work holding, clamping, fixturing, 0-point clamping, things like that. Give me a rudimentary education.
Sure. So whenever I discuss this, I like to start from the machine table and work my way up to the spindle. Okay. In the realm of work holding, that tends to be the most important area that you absolutely have to get correct, especially modular work holding, because everything's going to be in reference to what you have on the bottom of the stack. With 0-point, all we're really referring to is program orientation. Mm-hmm. Traditional work holding, traditional fixtures, you would be picking up the corner of a part or the corner of a workpiece in sort of either a dedicated fixture or a fixed jaw vise, picking up that corner, and then you would be programming out from that corner. Mm-hmm. A lot of times that was done with an edge finder, even a probe.
Right.
Nowadays, when you introduce 4th and 5th axis machining, now center of rotation becomes really, really important. So, with center of rotation, if you're off just a little bit, now the part doesn't rotate on that C-axis true. It's not concentrically aligned. So really, all the 0-point refers to is, because we're programming off center of rotation, we want to program from the 0 point of that part or the center of that part out. You can imagine the challenges that would come along with, setup times, trying to always make sure that you are perfectly on center of rotation. So what 0-point also allows us to do is create a scenario where we can repeat quickly and accurately off that same 0-point position. You could achieve that level of repeatability in a fixed jaw scenario with a workpiece stop or something similar. Mm-hmm. The issue is in 4th and 5th axis machining, if I have to use a workpiece stop, well, now it's cut off one side of the part that I could be machining in that operation. So, 0-point, again, we're just effectively talking about a programming orientation.
That makes sense. So how about the terms work holding, clamping, fixturing? Do those mean different things?
So when I look at the work holding umbrella, if you will, I think it really is just who you're talking to. Work holding fixtures, clamps, vices, chucks, most people are talking about the same venue of parts, if you will, the same general products. Really where we have to be a little more detailed is when we get into the realm of, when someone says chuck, we usually ask for a little more information, because if they're referring to something, when I think of a chuck, I think of, a round holding component that has 3 or 4 jaws. But some people will say, some people are alluding to a vise, 2 moving jaws or 1 fixed jaw.
Okay.
But I think, Jay, you were talking about, I think and I'm sorry I got off cuff a little bit when we took the break there, but I think you had asked me too about just the basics of work holding, right? And to start going into that a little bit?
Yes.
Perfect.
Please.
Okay. So if we start with work holding, if we start with the origins of what work holding is and the core concept, I mean, the real basics are a means of holding a part or a workpiece for use in for positioning and for machining or grinding or turning. It's how we're holding the part, and it's typically used, turning centers, jig grinders, milling machines. But we also see, our products being used on CMMs, quality assurance, part inspection, and even in assembly. The simple view of work holding has always kind of been, this is part of doing business. Like you said, it's oft overlooked. But now that we know it's something that can complement the procedure, it's interesting for me to always kind of go back and look at how work holding has evolved over the years.
Right.
So I think we mentioned very early on, at its core, it's securely holding the part, and then rigidity. We need to reduce as much vibration as possible. Enter that center of rotation like we were talking about earlier, and I mean, you don't even have to go back 5 years to just hear some horror stories about setup time. Quick exchange comes along. People want, more ergonomic, compact fixtures, and modularity becomes a real big buzzword in this next generation of fixtures. So for quick exchange, we're just talking about reducing that setup time, being able to take a vise or a chuck off a machine and set it right back down and know that you're going to repeat close enough where we don't have to refine that part in the machine tool.
So
modularity.
If I can jump in. So what I'm hearing there is that is a time savings as well as a potential savings of a scrap or reject part.
Absolutely. Yeah.
Okay.
Absolutely.
Okay.
Yeah. And along with that trend, I think naturally modularity comes into play. Modularity being able to achieve a high level of interchangeability among your different components. The best visual we could give anybody who's starting to look into modularity is just to envision the children's toy Legos, right? Everything always kind of clicks and clacks together real nicely, and when you could build a stack and then take it back down to just 1 or 2 fixtures very quickly, and more importantly, very precisely. So from quick exchange, now 4th and 5th axis manufacturing starts to come in, and now some other terms become really important. That compact, that lower weight, instead of just being an ergonomics issue, a lot of it comes down to being compact so that we have good accessibility to the part. And now because we have to reach 4 or 5 sides of that workpiece to machine it in one operation to make sure we're maximizing, getting the best return on investment of our 5-axis machining center, we need to be able to reach all those sides without jeopardizing that holding power, that rigidity, and the best way, that's traditionally always been done with a dovetail, and I think we'll get into that later when we talk about some of our products more specifically, but getting accessibility to the workpiece without jeopardizing holding power is probably one of the biggest challenges that we've really taken head on. And with the lower clamping pressure, again, because we're trying to do as much as we can in one operation, we don't want to have to go back and correct for workpiece deformation. So we're looking for fixtures to repeat. Oftentimes, torque wrenches have to be used. And traditional vices, you could walk up with a bar and a hammer, and you just wanted to get them as tight as possible. And because we're more compact now, we try to steer away from that. New alloys, new materials really require a little more finesse when it comes to accurately positioning that work in the fixture.
Gotcha.
So then now it's interesting because now automation comes along. And so now we've addressed all those challenges throughout the years, and now the biggest one that we see is really with automated machine tool tending, process reliability. I mean, that's the biggest buzzword going on right now is, when you're at home trying to enjoy some family time on a Sunday and you've got machine tools running, man, you got to know that nothing's moving, nothing's falling out of your fixtures.
You don't want that alarm to be texting your phone, right?
Exactly. So not only having all that great accessibility, all that holding power, all that anti-vibration, that compact, modular, quick exchange, high repeat accuracy, but now we want to do it wear-free. And so that is kind of the evolution of work holding, and that's kind of where we are right now with a lot of the offerings out there. Is we're just trying to catch all of those challenges in one great device.
So from a shop owner's perspective, what I'm hearing and when my ears would perk up is when there was the opportunity to take out variability in the process. And what I'm hearing is that the ability for interchange, the modularity, some of the automation stuff you talked about, a lot of it is sequenced around reducing variability. And specifically at Rapid, we had what I called the poor man's 5-axis. We had the trunnion tables.
Sure.
And I did not want us selling 5-axis parts. I wanted the trunnion tables to be used to manufacture 3-axis parts and reduce the number of setups. And as part of that, you didn't have to create other fixtures. You didn't have to take the part in and out of a work holding device. But I also knew every time that you did that, you ran the risk of not putting the part back in exactly in the same position. And it could be half a thou off, but you start compounding that, and as you said, the center of origin, you start making a difference part to part. So I really like the concept of the work holding helping to reduce the variability of and essentially take out or minimize the chance of error, which in my eyes was a scrap part, a reject part, which was dollars.
Absolutely. It's like a whole return on investment umbrella that you could look at, with our work holding. Your work holding should contribute to your profit margin. So, if your work holding is reducing your setup time, well, it's increasing your spindle uptime.
Sure.
If you have better accessibility, you have reduced cycle times. If it's a reliable process, you have less downtime. And if there's less operations, there's less handling. And I think anyone, from small, medium to large manufacturer can look at those 4 scenarios plus what you're citing and man, just be like, I really need to take a look at what's on top of my machine table.
You said it so much better than me, Eric. Thank you. So are there any other common words in the vocabulary of your world that we want to get under our belt in case we hear them?
Yeah, I think one of them I mentioned before that we'll probably come back to at some point is going to be Dovetail. But I think the ones that, a job shop, a shop owner should be asking themselves, a big one is, the reliability, process reliability, accessibility,
Mm-hmm.
holding power. And what's interesting about these terms is they have to do with work holding. It doesn't matter if we're talking about a 0-point plate or a pallet or a vise or a chuck. The words are all inclusive, so they cover everything we're talking about. Modularity. So if I had to pick a handful of those buzzwords that we should really be zeroing in on, it would be holding power, modularity, process reliability, and accessibility. And we'll come back to some buzzwords I think later, like Dovetail.
Mm-hmm.
That's a big one that'll kind of pop up over and over again, I think, throughout this podcast.
Just curious, what percentage of a shop's budget do you get to play with, or do you typically see getting spent on work holding?
That's a great question. Most of what we're doing is, new machine tool stuff. We do occasionally get in shops and bring them up to speed, but I think at least where we land the most new business is people are buying their first 5-axis, or people are trying to increase the profitability of like a new 4th axis or trunnion.
Mm-hmm.
And I would say, man, I think it would vary shop to shop, and it definitely is going to vary, from vertical to horizontal machining center. But at least for a new machine tool purchase, I mean,
Do you
and I know this
do you
probably
see
isn't
more
the exact.
spending? Yeah, do you see more spending on horizontals?
Yes, because in most horizontal applications, now we're talking, we're adding tombstones or other, we're adding other similar systems, pyramids, things like that, just because of the orientation of the spindle.
Mm-hmm.
But I don't know if I have an actual percentage for you, but I could tell you, like, if you were buying a new machine tool and you were going to buy, new fixtures, and we'll just say like, the 5-axis fixtures, the things, whether that's Lang or one of our competitors, you should probably anticipate that you're going to spend a minimum of about $15,000.
Okay. So it doesn't probably, because the price of machine tools varies so much, it's not necessarily a percentage, but more those are the hard dollars.
Correct. And, we find too, that percentage is relative to, some of these new machine tools with the large pallet pools and things like that. So,
yeah. All right. Well, let's find out who Lang is. Can you tell us about your company?
Yeah, absolutely. Lang starts in southern Germany about 30 years ago, over 30 years ago now.
Mm-hmm.
Our origins were as a job shop. That was how we got off the ground in the 80s. And what's interesting is all the systems you see now stem from challenges we faced in our own job shop climate, our own manufacturing facility. So early on, the very first invention that comes out of southern Germany, Gunter Lang, is the Variotech accessory jaws. So if you look at these older fixed jaw vices, a lot of them utilize a component called a parallel, which is essentially just a piece you would bolt to the front of the jaw to adjust the height of the part, to precisely adjust the height of the part. Well, I think that if you ask, if you go back and you ask a lot of shop owners how much time people in their shop might spend looking for a set of parallels to get that vise up and running, I think that they just got sick and tired of it in Germany. So the Variotech accessory jaws allow it bolts to the face of a traditional fixed jaw vise, and what it allows the operator to do is by simply introducing some air to the jaw with a simple air gun, they can create different parallel heights, end stops, different angles for the part, and they can do that all on the fly, and they can do it really, really quickly and really precisely. So that was I think the first product that came out of southern Germany. What followed that next would be our most popular product even today, and that was the CleanTech chip fan. And again, this comes from our own.
Yeah.
Yeah. That comes from kind of our own, people, operators blowing off parts in between parts at the end of the day. The next two inventions that came out of Germany, the Quick Point, Zero Point, and then the Macro Grip pre-stamping, again, I mean, the roots for those products are all in the manufacturing challenges that we were facing at those times. And the same rolls into the automation products we offer now. So that's always been a big part of our corporate history, and I think that's what's carried us a long way, is that the products we're creating were designed to solve challenges in our own manufacturing. So why wouldn't they work in yours? Now if we fast forward to 2020, we've got almost 100 employees plus 5 facilities all over the globe.
And where's the U.S. headquarters?
Absolutely. So we're here in Heartland, Wisconsin. In 2008, Gunther decided he wanted to set up sales, service, and small warehouse to better serve our U.S. clients. And from 2011 to present, we've been here in Heartland, Wisconsin. We've got a technical center, a full warehouse, CNC machines of our own that allow us to modify for customer-specific needs. We've got a training center for our sales staff, a full quality lab with CMM, a lot of moving parts for order fulfillment. But yeah, it's been here since 2008, which we always, whenever we tell that story, people tend to laugh. So like, why would he set up shop here in 2008?
Right.
Because it was a challenging time for manufacturing, but we weathered that storm, and we're here again in Heartland, Wisconsin, doing well today. So the tech center is, I think, one of the things we're most proud of. We created an area with CNCs so customers can actually come here from 8 to 5 Monday through Friday and see how on a CNC machine, see how we would make their product with our fixtures. So we're able to do live cut demos, and we're now a member of, since 2017 we've been a member of the National Association of Manufacturers. So that's opened up the doors for us to do some really cool stuff on Manufacturing Day, and so we're really proud of our little facility here in Heartland. But I think that if we looked at the history of Lang as a whole, the thing we're probably most proud of is that everything we've built has been, tried and tested in our own factories and solved.
Does Germany still make parts for other companies, or is it strictly supplying your needs now?
Correct. Yeah, we're strictly, and that's probably been for about 20, 25 years. We're strictly making Lang products now.
How about you? What's your background, Eric?
So, if I go back to the late 90s, I took my first job in manufacturing at a company in Oconto, Wisconsin by the name of Pendle Companies, and I was hired to work on process improvements, manufacturing efficiency, quality assurance, and how that all kind of, that's all kind of cyclical, right?
What type of products did they make?
So we made components for laser printers, scanners. So we manufactured photoconductors, toner cartridges. So basically the job there was I learned how to find and fix bottlenecks throughout a whole facility, from the receiving dock to the shipping dock, if you will, and everything in between. And you start to learn a lot of cool core values like, Kaizen 5S and Six Sigma, and some of those really cool metrics that can be applied to increase efficiency factory-wide, facility-wide. From there, I was there almost 10 years. I decided to take a job with a local, it's a little more than a lumber yard. They're a building supply retailer by the name of Menards. It's popular here in the Midwest. I did commercial outside sales. A high percentage of my customers were manufacturers, and so you start to see a lot of the needs manufacturers have, a lot of those moving parts that make up a manufacturing facility, and really started to learn that if you took the time to understand the products and the processes that your customer makes, you could become way more of an asset to them instead of just like a run-of-the-mill vendor, you know. And then I went from Menards. There was an opening here at Lang, largely doing the same thing, you know, efficiency, process improvement, but at this time it just involved CNC machines.
So stepping back to Menard, this is one of the, I'm always interested in how information, I'll use the generic term technology, gets transferred or job shop owners become aware of it. And it sounds like you started in the sales role at Menard, that a value you added to your customers was transferring technology awareness to them. Is that a fair statement, or is that something that you did, whether consciously or unconsciously, as part of your sales tools?
Absolutely. No, that's really the name of the game. And I think that's in this industry too. You know, if you really take the time to understand your client, you know, there's often times where I might be doing something, I might be in a different area or reading something that might not be affiliated with the industry and be like, boy, you know, I bet you Bob's Construction could use something like this. You know, and it might be something we don't even sell, but I think that, you know, that's the role you take if you really want to be an asset, you know.
So just pushing this a little more, the more successful shops, were they more open to you spending time with them, looking at you more than a salesperson? Or is that just me as a former salesperson being wistful?
No, I don't think that at all. I think that that's absolutely the role I had with a high percentage of my clients at Menards, and that's the role I hope I have with a high percentage of the clients here at Lang. And I think that's true because we will field phone calls of, you know, hey, this might be an area that you guys don't even deal with, you know, like turning. We get a lot of questions about turning, but I just want to pick your brain, sort of thing. And again, I think that stems from just trying to be a resource, you know. You know, if you position yourself as a resource rather than a sales guy, I think that the next part of that just kind of naturally happens.
So on the flip side, what I'm trying to do is open up the listener, the job shop owner, or perhaps someone who is part of the team, to evaluating the salesperson calling upon them, and perhaps they are not a resource and they really aren't adding any value. But if they do know what they're talking about, if they have a lot of experience and wisdom that can be extracted, it is worth taking the time to speak with them, whether in person or on the phone. I always thought that everybody eats lunch. So me taking a lunch meeting with someone, and this is when I was a shop owner, was not really taking anything out of my day, and it was an opportunity to get a lot of thoughts and new ideas from somebody who was into a lot of other shops. So I really encourage job shop folks to think of the salesperson as a consultant, as a resource, and not just someone trying to sell you something. So
Absolutely.
I got you away from the Wang there, but just
no, that's perfect. No, that's the kind of thing that I think that's important to mention too, Jay, and that's, you know, you really need to analyze who's in your shop, and, you know, are they on the team or are they not on the team? You know, and I think that one of the things we've always tried to do is, you know, give a certain level of value away. You know, we do a lot of free return on investment studies. We've always kind of, and some people look at me silly when I say this, but we've always kind of prided ourselves in not being afraid to walk away from the table. I've had plenty of conversations with shop owners where I've said, Lang really isn't a good fit for this. There's a better solution for what you're trying to manufacture than, I could probably go through and I could patch some things together. But if it's not the absolute best, if I don't feel that it's the best solution for you, I won't try and sell it to you. And that's how our entire sales staff is kind of programmed.
I think that's the long-term approach, and typically what I see with European suppliers. So I want to talk a little bit specifically about some of the products or the application, because the modularity and I think the way you described the quick interchange is very interesting to me. So how does the Lang product make that happen versus what you might see with a typical vise in the shop? Can you give me some comparison on that?
Yeah, no, absolutely. Let's start with vices. And if you don't mind, what I typically like to do, because you could go Google search 5-axis vise right now, and you're going to get a lot of pictures of a lot of products that always kind of look almost the same on the surface. Mm-hmm. So I kind of like to start with the component that separates us really from the other solutions that are out there. We'll come back to this dovetail that we talked about, right? So yes. When 5-axis machining kind of starts really taking a hold, that accessibility without jeopardizing holding power, the accepted industry standard for how we're going to hold that part becomes a dovetail. The dovetail is very simple. It's basically you have a flat on one side and an angle on the other, and then your clamp or your dovetail holder mirrors that, and by tightening a few screws, you're able to push against that angle, and you push it against the flat, and then the part is held. And the beauty of it is now you're only clamping on the dovetail, so the entire part, all the surfaces you need to machine, is above the fixture. So it's beautiful accessibility. And with some holders, you can even put dowel pins in there to help with part location. Again, it comes back to not having to have those longer setup times, not having to find that part in the machine tool over and over and over again. So dovetails work really, really well. So it's probably important to mention that. The only issue with a dovetail is that it requires a machine tool and a machinist to cut it. When we rolled off our pre-stamping, the idea was to give the industry the holding power of a dovetail, the accessibility of a dovetail, all the benefits of that technology without the downside, without needing that machine tool and that machinist. So everybody and their brother can sell you a serrated tooth vice jaw, and they work great. And that just means we're going to set the part in, we're going to close the vice. As we close to that max torque, the teeth are going to bite into the material, and they're going to hold as they kind of penetrate that material. And they work. The real issue comes into where we're headed in medical and aerospace and some of those industries. Some of these alloys like stainless, titanium, Inconel, the hardness factor of those don't make them good fits with a traditional serrated tooth vice jaw. The answer as to why they don't is very simple. It comes back to that buzzword, process reliability. If I use any vise, mine included, to bite and hold those harder work pieces over and over and over again, the teeth are going to wear. And anybody that's been in this game long enough will probably tell you that component wear, especially when it comes to fixtures, work holding vices, chucks, that's the no zone. I mean, that's just, especially again, if we come back to now we want to introduce some automation. So I want to be home with my family on Sunday while the machine tool runs. If parts start moving, things get ugly. So with the Lang tooth serrations, we hold the patent on that pre-stamping technology. So essentially what we're doing is we're pre-stamping the contour of our vice tooth serrations onto just less than 3 millimeter material of the workpiece. So when we go to load that part in a Lang vise, the tooth has already penetrated the material. That was done offline in like 3 seconds. So all a Lang vise tooth ever has to do is sit in that pre-stamped pocket and hold the part.
So just thinking this through, and I've seen this for the listener who I encourage you to go to the website and you get a little more of a flavor. That number one, what I liked about it is it's essentially a cart that will put the serrations into the material so that you don't have to spend X number of dollars on a machining center and a machinist. And it happens pretty quickly. So what do people just do it right at the work centers? Is that the
Yeah, exactly. You've got it on a workbench, or like you said, you've got it on one of our movable carts. And yeah, I mean, it's just placing the workpiece in this hydraulic stamping vise, and in 5 seconds max, it's ready to load into the machine tool vise.
Right. So it sounds like you have matching serrations, we'll call it, in your work holding products.
Yep.
Absolutely. How do you know that those are going to align exactly where you want them to? Because there's the serrations have some distance there. So how does that, if you put the serrations into a piece of material and then the next one goes in a little bit differently, how does that create a consistent alignment? Or is it because when you're machining the part, I guess you're starting with a piece of billet, that it sort of doesn't matter where you start?
It's probably a little bit of both. We have two main things working for us as far as accurate position of that raw stock. But yeah, the systems in and of themselves are largely designed for raw stock. So the assumption is being made that you've given yourself enough workpiece around what you have to machine to accommodate for, a few thou in one direction.
Okay.
But
once you've locked that in, then you're set. It's gonna clamp the same way every time. Gotcha.
Exactly. And the tooth contour, so that the teeth repeat center to center plus or minus 5/10,000ths of an inch. So it's really precise as far as lateral placement, precise enough that you don't need to use a work stop. That being said, the teeth are spaced every approximately 1/4 inch. It's 6 millimeter, right? So we always make the joke that your operator could load the part 6 millimeter plus or minus 10 microns in the wrong direction. So we actually have a really low cost accessory that we sell in conjunction with the unit called the center marking tool. And what it does, the top of all of our vise jaws are scaled. So the center of the jaw is marked 0, and then it goes out in increments from there to the edge of the jaw in both directions.
Okay.
So we have our center marking tool is going to put a nice fat line on the workpiece, so your operator can line that up with the 0 marking on the scale, and doesn't even have to think about it.
Great.
But so the beauty on the backside of that is now, because that Lang vise jaw only has to hold, Lang vise jaws, those tooth serrations last forever. It's the best process reliability you'll get with that type of vise.
Because you are essentially, you have both the stock and the work holding jaws serrated, I would assume that you are locking tighter, which would allow you to have more machining force on the material. Is that a correct assumption?
Well, holding power is always going to be relative to the strength of the spindle in and of itself. What we get with the tooth serrations being fully seated is we get significant vibration reduction. A lot of times with these devices, that's your enemy. You start picking up some vibration, before you know it, it turns into a lot of vibration. Things start moving, right? So if you look, the whole design again of these self-centering, these 5-axis vices is, low actuation force that translates into high clamping force. So the smallest vise we make only requires about 23 foot-pounds of max torque, but that translates into 1,500 pounds of clamping force. But the problem with 23 foot-pounds of max torque means that even in a soft material like aluminum or even like a composite, when I tighten my vise to 23 foot-pounds, the teeth bite in a little bit, but it doesn't fully seat that tooth. When I'm using pre-stamping, I'm creating a full slot for that tooth to go into. So we really get a lot of substantial vibration reduction using that technology.
That makes a lot of sense and wasn't something that I was thinking about, and I would assume that vibration, that's one of the downstream variabilities that you start to want to eliminate, or you are thinking about once your workpiece is really securely being held.
Absolutely. I mean, you got, at the very surface, surface finish is, right at the top of things that are affected by vibration. But, we're dealing with customers that are trying to machine within 2/10,000ths of an inch. The littlest amount of vibration can start throwing those tolerances off. So it's really important that we're holding that thing rigid. Now, when we talk to 0 point, really the thing that separates laying on the 0 point side of it, Jay, is I think the pull stud. The Lang Quick Point is set up in a way that you can really put. You can buy a 4-pack of the pull studs or the clamping studs that interact with the 0 point receiver. That it's what kind of holds that vise, holds that fixture down to the machine table, and that's also the component that makes sure that we're holding it precisely in position, that it's repeating. The pull stud is one of the most important parts of that whole system. If the pull stud is poor quality, they can shear. If the pull stud isn't accurate, your fixture can stick or your repeatability is lost. We've always, we've been doing this a long time. We offer a 4-pack of pull studs at a real competitive price. On the job shop side of things, why that's important is really for standardizing, and really for, I think a lot of shop owners look at new fixtures, like getting in bed with a new fixture company, like, I have to rebuy everything. This is going to be insane. And it's just not the case. With the pull studs, because they're sold individual, you can buy a 4-pack for starting under $70 for 4 of them, and you can convert all of your old fixed jaw vices, those dedicated fixtures you've made over the years. You put the studs in the bottom of those, and now what you've done is you've taken all that fixturing, you've redeployed it, but you've also kind of increased its profitability because now it's quick exchange, high repeat accuracy. So it's a great return. And I think for a job shop owner, maybe even any manufacturer, we look at the level of standardization that we achieve. When we're looking at, okay, well, we're quoting this part for someone, how the heck are we going to hold it? Well, when you get into a system like ours, well, okay, we're either going to put studs in it because we could put the pull studs right into the workpiece if we wanted to, or we're going to stamp it. I mean, it really starts to cut that list down, and we can spend a lot less time.
So the studs are what allow you to take the work holding unit and say from the 5-axis and put it in a CMM or put it into a 3-axis machining center to get the 6 side. Is that the type of thing that I'm hearing?
Yeah, absolutely. So what you see is, that those studs are what are going to ensure that we're going to repeat on and off that machine table over and over and over again. So,
Right.
You cite the CMM. That's a great example. Whenever we are quoting this, we always ask, do you have a CMM? And if the answer is yes, then we'll try to quote that extra quick point plate to go out on the CMM. Envision if you have a workpiece in a vise, and that vise has the pull studs that make so that it can be integrated with a 0 point, or in our case, the quick point system. So we machine our workpiece. Okay, let's go check some measurements on the CMM. Imagine taking the whole vise with the workpiece in it over to the CMM. You set it in the plate you have over there, or the quick point plate over there. You take your measurements. Well, if you have to make any adjustments, you put the whole fixture back in the machine tool. You're repeating it less than 2/10,000ths. So you just have to, adjust your tool offsets, and you're good to go. But that to me is, one of the really unseen advantages, and I'm glad that you brought that up. But yeah, or if, another popular thing is, let's say you have a vertical machine center with a 4th axis on one side. Well, if I have a 0 point quick point plate on my vertical table, and I have a 0-point quick point plate on my fourth axis, I can do my 4 sides, and then I can pull it off that fourth axis and now set it on the plate I have on the vertical table and do my top.
Gotcha.
It's just...
Yep. Yeah, you don't want to be taking the part in and out. I like it.
Exactly.
I like it. All right. So anything else? I know that you have some automation products, but I would encourage the listener to go to your website to check those out. But I don't want to get into, because I think most of the listeners are not using automation, but give us a quick 30-second description of what your automation tools are doing before we move on.
I think the best thing about it is it's set up with the modularity that makes our fixtures so popular. So if I'm a customer, I can get into a laying vise and a laying plate for under $2,000. And because the system's so modular, I can build over time. I can build organically. I can really manage my investment, right? I'm going to add a vise here, maybe add a plate there. Well, the same holds true for the automation. Lang Robotrex uses the same fixtures that you would use on just your normal 3-axis or 4th-axis. So by the time the customer gets to that point where maybe I want to put a Robotrex on this machine tool, because you can retrofit them to anything, they already have 90% of the key components that they would need. So you follow where I'm going, Jay? They don't have to reinvest now in all these new fixtures and chucks. And I'm with you. I would encourage people to look at it on the website. And if I could share any industry wisdom when it comes to automation, I would encourage people to maybe call us or call some other automation providers and really learn the difference between workpiece exchange versus fixture exchange.
Gotcha.
The quantities really determine which one you need, and I think where people will get the worst return on investment is if they don't understand the differences between those two and why you would roll one out as opposed to the other. We deal all in fixture exchange work holding, which is what allows us to kind of roll that modularity into the automation end of things. But there are plenty of scenarios where it makes more fiscal sense for a customer to focus on workpiece exchange. And we're always willing to help do that return on investment, and we're always willing to help educate. But that would be what I would lead into if we just a few minutes to talk about automation. In my opinion, that's the most important message to get out there: is make sure that you're looking at that you understand the difference between the two concepts and which one is best for your facility or your process.
Sure, and I'm sure it depends on the specific scenario of the part being manufactured or group of parts. So what I'd like to ask you, Eric, is let's pretend that I am a job shop owner, or look back at when I was a job shop owner at Rapid, and I say, this is something I want to try. This is something I want to bring in my shop and see if it makes sense. And I hear the 4 and 5 axis. That to me makes a lot of sense. But what if I only am cutting on 2.5 axis or 3 axis applications? Where might a high precision work holding solution make sense, and how would I get started? How would I implement that?
Great. It's important because everything is so modular, there are levels to it, right? So if we were just walking into your facility and it was, all 3-axis machines, my advice to you would be, at this point in time, it probably doesn't make much sense for you to invest in a self-centering vise or into our pre-stamping technology. But I've never walked into a facility that cannot have an awesome return on investment with a QuickPoint 0-point system or the CleanTech chip fan. So my advice would be those two systems can help anyone, anywhere, at any time. Being able to not have to constantly find parts and take offsets, knowing you're going to be able to adapt anything very inexpensively to that system. And then, clean tech, in my opinion, that is the easiest process in your whole facility to automate, and it is the best return on investment you'll ever get.
Yeah, that one seems like a no-brainer. What is that? What does that cost?
So they're going to start at $235.
Sure. So that's a easy investment to try out. And I'm going to get on my soapbox here, and if you will say pause here for a sec, Eric, I really want job shop owners to have this investment mindset, this way of looking at spending money as it's an investment. You make good investments, you make bad investments, but you make investments, and you only lose if you don't learn something from a bad investment. If you have an expense mindset, then you're always trying to save money. And I have seen that is what keeps job shops from growing. And by the way, if you're not growing as a job shop, you're shrinking. So
absolutely,
you really need to step back and say, I've heard job shops say, I don't really want to grow. Well, you're either growing or you're shrinking. So you have to make a decision. If you say, I don't want to grow my business, and you have really said that I'm okay with shrinking my business. And is that really what you are saying? So anyways, unpause that. We want to try the chip fan, and if we wanted to bring in some of the 0-point clamping tools, what's a good number that I should budget for an investment there to try something out?
I would think that you should expect to at least spend $1,000 on your first quick point plate.
All right.
That would be the least amount.
Okay. I'm also thinking this really gets into the skills gap that's always talked about out there, because the machinists who you could count on to overcome the slop in less precise or traditional vices and other holding equipment, they're just not as available to be found today to hire.
No.
So you're hiring people who don't really understand the importance of really being precise in your alignment when you put a workpiece into a machining center. So I think that this technology is a great way to help make sure that you're still making good parts with the availability of the people who are there today to hire. So
absolutely, because what you're doing is you're controlling position, you're controlling orientation, and you're controlling how firmly it's held. You're controlling all those things, and really all you have to do is train someone to tighten the torque wrench, and you achieve those three really key components of the whole process if you think about it.
You again said that so much better than me, Eric. Thank you.
I'm sorry.
So before we wrap up here, can you give me one or two stories where you made a difference in a shop?
Yeah, I would love to. And then, I do want to, hopefully we have time, because we do offer a challenge to job shops, small, medium manufacturers, on how to look at their work holding moving forward. So I'd love if we have the chance to get into that. But our two biggest success stories, I think, really also deal with what you were just talking to about skills gap. So I'll start with that one. Got a large customer in Pennsylvania. They had always held things with dovetails, and they were a big 5-axis shop. But over in the corner, they had these 3 vertical machines and this one machinist, and all they did all day long was prep work pieces. Now, it's important when we talk about customers who want to get into fixtures like these because they want to reduce the number of operations. Well, prepping your workpiece is an operation. You're cheating if you don't count that, right?
Right.
So we got 3 vertical machines and 1 machinist, and all he does all day long is cut dovetails so that the parts can go into the 5-axis machine to get manufactured. So they're hitting a growth spurt. They want to bring in a few more 5-axis machines, but they've hit a capacity level as far as workpiece preparation. So now they have to ask themselves, we will need to probably buy a 4th vertical and consider hiring another machinist to keep up with the demand for these workpieces going over to these 5-axis mills, right? That's when they brought us in. And we drove out there. We took a stamping unit with us. We like to kill 2 birds with 1 stone, so we kind of had the whole team there. So as we were presenting MacroGrip pre-stamping to them, we were also kind of subconsciously training them how to use it. It's kind of that simple. And needless to say, they switched over to our system. Those verticals don't exist anymore. They were sold off and used to purchase more 5-axis machine tools. And that machinist has been redeployed where you want your machinist to be, right? You want that skill level running the 5-axis. Maybe even taking that extra time to think about how to do things more efficiently.
Right.
Second success story, large aerospace customer in Colorado. When we got out there, they're machining these 6-inch by 6-inch by 3-foot long, just monster bricks of titanium. And they were using dovetail holders again, but more like a Technogrip fixture. But to fast forward, the workpiece prep was about an hour and 15-minute long per workpiece. The amount of material...
Wait, an hour and 15 minutes?
A workpiece prep, yep. And the amount of material needed... Now, of course, I'm going to tell you the best stories I have, right, Jay?
Sure.
So the amount of material needed of this titanium just to prep for this Technogrip fixture was $30 per workpiece. They're machining 300 of these a month, right? So an hour and 15 minutes to do this face mill operation because the bottom of the part became a datum, and then machining dowel pin bores for locating, and then, of course, the Technogrip interface into this. So an hour and 15 minutes, $30 worth of material just to be able to put this thing in the 5-axis. We showed up in Colorado. We had sent a stamping unit out ahead of time, and we showed up. We stamped some work pieces. Again, we had the whole team there, so we're educating as we're demonstrating, and literally that is down to a 5-second operation now. They're saving $30 per work piece. I mean, that there is obviously an extreme case, but that particular company's saving, $500,000 a year by switching to the system.
Yeah, that's amazing. Wow.
Yeah.
All right. So
where it works, it tends to really work well.
How about in the 0-point clamping? Any success stories that come to mind there?
Yeah, I think it's the same thing. We've walked into a lot of places that are kind of doing things the old way, loading the dedicated fixture or loading the old Kurt Weiss onto a table, and you're spending some time running an indicator over things to make sure it's trued up, tightened down.
Yep.
And I mean, that's really low-hanging fruit. We're constantly going into those facilities and getting them a quick point plate, and people are instantly kind of tuned in to what we're trying to do here. But yeah, the 0-point, it's probably the most common because it is such a good return on investment. I mean, there's thousands of those stories.
All right. So you mentioned a challenge, and we're getting close to where we do need to wrap up, but go ahead and throw that out there if you want to do that.
I would just say if you're a job shop, a medium, small manufacturer, do you measure your work holding performance? I guess you don't know what you don't know, right? And so it can be as simple as a time study, monitoring your setup times. You could do like throughput yield or something where you're measuring the amount of good parts that go in versus, or parts that go in versus good parts that come out. Or you could get as detailed as something like overall equipment effectiveness. We invite, when people call us, again, we try to be a resource, so we're willing to help you with those studies, but your work holding should be contributing to your profit. If it's not, it's time to measure it. And so we challenge people, do you measure your work holding? You should start.
I think that's a great way to look at this area. And again, it's not sexy and it doesn't involve computers, but it can make a difference. And I would also think that as a job shop owner listening to this, if I have a particular part where vibration is an issue, perhaps it is really that the workpiece is not being held tight enough, and there might be an opportunity there. So one thing since you're in so many shops, are there any, the shops that you see that are super successful that you think of as top shops out there? What are some best practices outside of work holding that you see them implementing in their shops?
Well, I think when you walk into those shops and you see, that 5-axis utilization, or you see that, okay, so they've made some substantial investments in their manufacturing, right?
Mm-hmm.
You see that just naturally drives a lot of other technology. So when I walk into like what I think are top shops, and I found it's not necessarily size relative, I walked into
absolutely.
Yeah, absolutely. But I always look at are they programming offline? What kind of software? What kind of shop cleanliness is a big one for me. When you walk in,
does that correlate?
Yeah, absolutely. Absolutely. I think it all comes down to those lean principles that make a shop successful. You walk in, I'm seeing more and more shops that are painted light gray and white, and it's like, you walk into those places and and you get a sense right away, well, if they've invested in that ideology, that end of the whole lean spectrum,
Mm-hmm.
shine, that's the S, shine.
Mm-hmm.
It tells me that, okay, so here's a place that's obviously got their head screwed on right. And those principles tend to be contagious and tend to flow into all other areas. So usually when we see a real clean shop when we walk in, then you naturally start to see, I think it's maybe cool. I don't know if it's necessarily an indicator that, but when people have, they're programming offline right at the machine tool. So you have those machinists that are trained, that are well versed in that CAD CAM software,
Mm-hmm.
Seeing the cool cutting tool concepts, high speed machining and those techniques. You can hear that. I can hear that when I walk into a shop, and
so
those,
how
that's
does
really what I'm
that
seeing.
sound differently?
Well, when you walk in and someone's really hogging out a piece of aluminum, sometimes depending on the quality of that cutting tool, you can feel it.
Right.
So, but yeah, that high speed machining, I think that people that have done it know that sound where it's without impersonating it. I don't know how to describe that for you, Jay. But,
All right, we can move on from that. So, but I'm really interested in the commonalities of the shops who are high performers, and that's what I'm trying to eke out of you here, Eric. And anything
Absolutely.
else that you see that I guess probably the best way is when you walk into a shop, you just know that they are making money, highly efficient, and just a shop that you want to be a partner with.
The first two determining factors, I'll tell you, it's organization and cleanliness, because that's, to me, that's the big one that tells me, okay, so I guess that those are always the first two that grab me when I walk in,
And on the flip side, are there things when you walk into a shop you're like, oh, there's going to be issues here, or the mindset is not a growth mindset?
There was one time when I worked for Menards that I walked into a facility. Now, mind you, it's Wisconsin, so it's winter, so there was some my feet were a little wet, but I mean the floor was pretty slick with oil, and I took a ride and I fell down. So that was I think that really it's the biggest thing I run into, Jay, is there's still a level of closed-mindedness for some of the technology that we talk about. There's really, I have walked into some places where people still have that, different ideology about automation and about, that vice will never hold that. And that's part of the reason why we started offering 2-week, no obligation free trials. Because someone who's been in the business, 35, 40 years doesn't think your vice is going to hold his part. There's only one way to change his mind, and that's to let him machine on that vice, So we do still run into a lot of that. It'll never work. You don't need that sort of thing, and that's usually an indicator to me that I don't want to say that a shop's suffering, but that like you had said previously, like they might start, at some point starting to feel a loss in business, or it's about staying competitive.
Sure. Well, this is a good place to end here, I think, today, Eric. And I really appreciate you coming on and chatting with us. I love getting into the nitty-gritty of work holding and fixturing and clamping. And the gears are churning. There's so much for me to process and digest here and think about how I might have been holding Rapid back by not taking a closer look at the types of technologies which we talked about today. But what I'm hearing is this is a great way to take another variable out of your shop, particularly as you move towards automation. And automation can mean different things, of course. So,
absolutely.
Yeah, it's
such low-hanging fruit. You know what I mean? It's just so easy to grab it and change it.
Yeah. Well, incredibly powerful. I, again, am very appreciative of you being open. My other podcast guests and some of the other folks who I mentioned are using Lang, and you're not a huge company, so the fact that you're starting to really make inroads in the shops is very impressive, and I think a trend of where machining is going. So anything else you'd like to add?
No, I just want to thank you again for inviting me to be on your podcast, Jay. It's been a lot of fun.
How would a listener reach you and Lang?
The best way would be to email us. You can do that through the website, or you can just email sales@lang-technovation.com.
And your website is Lang, LANG-TECHNOVATION.com.
Yes,
you
sir.
also are, I saw you on LinkedIn, on Facebook, any other platforms, social media
Instagram.
that you like? Instagram, okay.
Absolutely.
You guys are all over it.
Very fledgling YouTube channel, but we're working on it.
Great. Well, thanks again for coming on board. And for the listener, we really appreciate you making us a part of your day today. Thanks for tuning in. And at the start of 2020, I want to wish everyone out there the next best year of your life. Expand your growth mindset and go out and try something new. You'll probably succeed, but if you fail, again, you only lose if you don't learn something. That's it for now, and until next time, keep those spindles turning and those lasers cutting. Have a great day.